All right, in this video, I'm going to go through the last four multiple choice. So in this case, we're going to find the volume generated by revolving about the x-axis, and the region is going to be y equals x cubed, below the line y equals 0, and between 0 and 1. So x cubed is going to look like this, and we need to go below the line y equals 1. And we know we're only going to go between 0 and 1, so that's kind of nice because that's going to tell us our stopping points here. So we're going to take this and we are going to rotate it around the x-axis here. Now, as I rotate this around the x-axis, I can see that there's space between the region and the axis. So I know that this is going to be the washer method. So integral, my shell integral is going to be pi integral of my radius squared minus my radius squared. And it's a horizontal line, so dx. And so the first thing I need to do is I got to look for my biggest radius. So I'm going to go from the axis up to the farthest part away of my region, which is going to give me that line of 1. And then I'm going to go for my smaller radius. So again, I'm going to go from the axes going up to the closest part of the region, which is following that curve. So that's going to be x cubed. Now this one, you can see that they did leave it in terms of pi for the answers. So if you're typing it into your calculator, you just want to do the integral, and then you can go ahead. Oh, we forgot our bounds here. Hold on. So then we got to go bounds. We know we're 0 to 1. Those were given to us because we're stopping at x is 0 and x is 1. So now if we just type in that integral, leave out the pi, 1 squared minus x cubed squared, which is going to be x to the 6th, dx. And so when we get this part, it's going to end up giving me a fraction of 6 over 7 multiplied by the pi that's in front. So our answer should be E, 6/7 pi. All right, next one, we're going to find the area of the region. So remember, area, not volume. When we talk about area, area is going to be your upper curve minus your lower curve. So we have the region bounded by the y-axis, the line y equals E, right, and the graph of E to the 3x. So if you want to try and graph this, to graph this y equals E, you're going to go e to the first power. Now we know that that's going to be a straight line going across. And then e to the 3x is going to be, so here's E, and then e to the 3x. Now starting at the y-axis, we know anything to the 0 power is 1. So it's going to be this really small little region right here between that line of y equals 1 and e to the 3x. All right, so the first thing I'm going to do is I'm going to figure out this intersection point. So you can figure out that intersection point on your calculator. We know that this one over here is an x value of 0. So that's 0, 1. This intersection point up here is going to be 0.333, so 1/3. And then the next one is 2.7182, which is the value of E. So 1/3 E is that ordered pair. So this integral is going to go from 0 to 1/3. And we're just going to do the upper function minus the lower to find that area between the curves. So the upper function is E. And I'm going to subtract off the lower function, which is e to the 3x dx. Oh, now as I look at all these answers, none of these answers are in decimals. They are all here in terms of e. So let's take this integral by hand. So the antiderivative of e is going to be ex, because e is just a constant. So it would be like the antiderivative of 2 would be 2x. Now as I integrate negative e to the 3x, I am going to need u sub. So my u is 3x, du is 3 dx. So 1/3 du equals dx. So that would be filling in that negative 1/3. Integral of e to the u is e to the u, so e to the 3x. And then we're going to evaluate that from 0 to 1/3. So I'm going to start by plugging in 1/3. So I'm going to have 1/3 e minus 1/3 e to the 3x times 1/3, so 1/3 e. So that's all going to cancel out. 1/3 e minus 1/3 e. And then I'm going to plug in 0 to everything. So 0 times e is going to be 0. 0 plugged in here is e to the 0, which is 1. So minus 1/3. So I'm going to have negative 1/3, which will be positive 1/3 for an answer of A. All right, next one. If we want to, the region is enclosed by the y-axis, the line y equals 2, and the curve y equals the square root of x, revolved around the y-axis here. Okay, so this is our first vertical one. So we have square root of x, and then the y-axis and the line y equals 2. So we're rotating this piece. And we're going to rotate it around the y-axis. Now, I can see that in this case, my region is touching that y-axis the entire time. So this one is going to end up being your disk method. So pi integral of my radius squared. Now, this is in terms of the y-axis of vertical line, so we're going to write dy at the end. Then we can go ahead and look. This is going to give me from 0 to 2. We're going to go in terms of y since we're going around a vertical line. And then the last thing we got to do is we just got to look and write our radius in. So from the axis going up to the line, it's always following this curve. Now, this curve in terms of y, we need to solve this equation to be x equals. So I'm just going to square both sides, so it's y squared. So we're just going to go from 0 to 2 of y to the 4th. This would be an easy one to do by hand as well. Let's go ahead and do that. Practice redoing them. So y to the 4th. So pi integral from 0 to 2 of y to the 4th dy. So the antiderivative of y to the 4th, add 1, and then divide by that new exponent, evaluating from 0 to 2. So this is going to give me 1/5, 2 to the 5th power minus 0. And then we're going to multiply the whole thing by pi at the end. So 2 to the 5th is going to be 32 divided by 5 times pi, which is going to give me an answer of A. All right, last one that we are going to do here for the multiple choice. We have the graph x cubed, the line y equals 8, and x equals 1. And we are going to rotate this along the graph x equals 2. My picture is not drawn to scale very well. It's going to go around this line right here. Because this point right here with that y equals 8 is going to be 2, 8. X equals 1. This would be a point of 1, 1. And then this point right up here is going to be 1, 8. Okay, so we're going to rotate this around this line that we have up here. That vertical line of x equals 2. So this is going to be a washer problem. So pi integral from radius squared minus radius squared, again, dy. So the first thing I'm going to do is look at my bounds. Now I'm going in dy, so I want my y values. So this is going to go from 1 to 8. So if I'm going from 1 to 8, then looking at these right away, I can cross off my pieces there. Then the second thing that I can look for is my biggest radius. And the biggest radius is going to be from my axes going over to the farthest side of the region. And that farthest side of the region is right here. And that is 1. But I'm going to go from 2 to 1. So this is going to be 2 minus 1 squared. Then I'm going to go to the closer radius, or the closer part of the region. From the axis of rotation to the closer part of the region is always following this curve. So this curve is x cubed, but we don't want it to be x cubed anymore. We want it to solve for x. So that's going to be the cubed root of y equals x. But that curve is coming from that line of 2. So bigger minus smaller, this is going to be 2 minus the cubed root of y. Now, if we look, we don't see this exactly anywhere here, but we do see 2 minus 1 is going to be 1, so that's going to be 1 squared, which is still 1. And so that answer here is going to be B. All right, let us know if you have any questions.